So this is actually an example. You said two chemicals A and B are combined to form a chemical C. The rate of the reaction is proportional to the product of the instantaneous amount of A and B not converted to chemical C. Initially, there are 40 grams of A and 50 grams of B, and for each gram of B, 2 grams of A is used. Now, it is observed that 10 grams of C is formed in 5 minutes. Now, how much is formed in 20 minutes? And what is the limited amount of C after a long time? And then how much of chemicals A and B remain after a very long time? It's a very long question, quite confusing. It might be confusing to some, but if you look into it, you find that it's quite interesting. Anyway, to solve something like this, what's the first step you need to take is what we observe is handling a question like this that look kind of long. It's better you handle them statement by statement. Now, for the very first statement you have here is two chemicals A and B combine to form a chemical C. So let's say this is a chemical here, A and B, they combine to form chemical C. And then we are told that the rate of the reaction is proportional to the product of the instantaneous amount of A and B remaining. A and B remaining. Now, what determines the rate of the reaction? What determines the rate is actually the amount of C formed. That's what determines the rate. So I'm going to let X, let me write X of T this time around, be the amount of chemical C formed at time t. So according to this statement here, it says the rate at which chemical C is formed is actually proportional to the amount of A remaining times the amount of B remaining. So this is what we know right now. So I've been able to I've translated the first and the second. Now let's continue. It says initially there are 40 grams of A and 50 grams of B initially. So I'm going to continue by saying let A of T be the amount. So my AMT here represents amount, the amount of A used at time t, and let B of T be the amount of B used at time t. Now, according to what we've been given here, we're told that when t equals 0, because it's initially, so when t equals 0, the amount of A is 40. So when t equals 0, so maybe let's not confuse things here. Let's call this remaining, since we've been using remaining here. So let's call this remaining, and let's call this remaining too. So we have A of 0 equals 40, and then we also have B of 0, as when time is 0, the amount of B is 50. And then we're told that 2 grams of A, for each gram of B, 2 grams of A is used. So what that statement means is for each gram of B, for 1 gram of B, you would have used 2 grams of A. But how many grams of B are we using here? So we're using B grams, so that implies that for B grams of B, that means you must have used 2 grams of A. And then we're told that A grams combines with B grams. So since A grams combines with B grams, it implies that that A must actually be 2B. So A equals 2B. So that is my A. So that implies that, so we know that A plus B, they combine to form X. And now we know A equals 2B, so that implies that 3B gives us X. So which implies that B equals X all over 3. So B equals X all over 3, and then if B equals X over 3 and A equals 2B, so that implies that A equals 2 times B, which is going to be 2x all over 3. So this is the amount of A used at time t. This is the amount of B used at time t. So if this is the amount of A used at time t, then we could just come down here that says amount of A, which is going to be K times, so amount of A remaining, since the initial amount is 40 and we have used 2x all over 3, so therefore the amount remaining is going to be 40 minus 2x all over 3. So similarly, for the next one, the initial amount is 50 and we have used, that's the initial amount here is 50, and we have used x over 3. So it implies that the amount remaining would be 50 minus x all over 3. So this is going to be the differential equation I want to solve. So we have dx dt equals k into 40 minus 2x all over 3 into 50 minus x over 3. Now to solve this, we could simplify this as k into, when you take the LCM, you have 120 minus 2x all over 3 into 150 minus x divided by 3. So 3 times 3 is 9. So this is going to give us k all over 9 into 120 minus 2x into 150 minus x. So this is what you get. But then k all over 9 is another constant, so which could be written as, I could call that k1 into 120 minus 2x, 120 minus 2x into 150 minus x, 150 minus x. So this is my differential equation I want to solve. So therefore, to write the differential equation, what we have is dx equals k1 into 120 minus 2x into 150 minus x. So how do we solve this differential equation? You observe that we could separate all the x and all the t's on one side. So in doing that, you have dx all over 120 minus 2x into 150 minus x equals k1 dt. So that's the first thing you need to watch out for when you're doing that. Now let's solve this. So we integrate both sides now. So when integrating both sides, what we have is, we have dx all over 120 minus 2x into 150 minus x. Now equals then the integral of k1 dt. Now to solve this, you need to resolve this into partial fraction. That is 1 all over 120 minus 2x into 150 minus x. You resolve that in a partial fraction. And on resolving that in a partial